All right, I'm going to take you through what we did in class, Intro to Logarithms, or some people just say logs. So we know we've studied this function, exponential y equals 2 to the x, which is right here. And now we also know something about inverse functions being symmetric about this line, y equals x. And so I've filled in the table already for this first function. And now what we want to do is create a table for the inverse. And this is kind of how we're going to discover the graph of a log function, because logs and exponential functions are inverses. And so remember, the inverse, all we have to do is switch the x's and the y's. So if this x is -3, then that means f inverse of x is -3. This is the y coordinate, and so that's going to switch and become the x coordinate. So all we're going to do is switch all the x's and y's around and see what that graph looks like. Because if we do that, we're creating the inverse by definition. So the point 1, 0, let's start there. Point 1, 0 is here. It's easier to graph these whole numbers. 2, so right 2, up 1. Why did that disappear? And then right 4, up 2. So 1, 2, 3, 4, 1, 2. And then right 8, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Right 8, up 3. Okay, now let's go back to the fractions. 1/2, -1. So we go right 1/2 and down -1. This. And then right 1/4. So that's pretty hard. That's 1/2 of a half. And then down -2. And then the last one, 1/2 of a half of a half. And down -3. So the point is, notice these are getting smaller and smaller. And so the asymptote is the y-axis. Asymptote. The asymptote of the exponential is the x-axis. So they just switch, and then this ends up like that. And then we get this nice symmetric curve where these distances are the same, these distances are the same, these are the same, these are the same. So, and that is the equation of this would be, instead of this 2, we write log base 2 down here, and the x goes inside of the log in parentheses, like that. So this is the inverse of 2 to the power of x. That's how we rewrite this. We go from exponential form to log form. So we're going to practice doing that. So here we go. Like I just said, y equals log base b. So log base b of x, I like to put that in parentheses, is the same as b to the y, b to the power of y equals x. So if we had let's just make up another exponential function with a base of, let's say, 5, and let's say the power is 3. Okay, we know that this equals 125. Maybe we don't know that, but we can use a calculator to know that. 5 times 5 times 5. If we rewrite this as a log, that means the 5 is the base, so that becomes the b. B stands for base, log base 5. And now the power is y. So notice y is over here. So this power has to be over here, and the 125 is the x, and the x is inside. So equivalently, we would say 3 is equal to log base 5 of 125. So that's converting between the forms. Now, that's basically what our job is going to be for this section. Evaluate, like, what is this equal to? It's just equal to some number. It's equal to 3. And so the way I know that is by I'm rewriting this in exponential form. 2 to the power of what equals 8. I would only ask you to do these for ones that aren't going to be decimals. So 2 to the power of 3 is 8. So that's how we know that this actually has a value of 3. Okay, this one, 4 to the power of what equals 16. so we should recognize that's 2. This one's a little bit harder. 5 to the power of what equals 625? You might need to check. Just do your powers of 5. 5 times 5 times 5 is 125 times 5 again. So that's going to be equal to 4. This one is equal to, just count the zeros. If it's log base 10, we have 1, 2, 3, 4, 5. So that's going to tell you what it's equal to. 10 to the 5th is equal to 100,000. Okay, this one's a little bit harder. 6 to the what power is 1 over 36. And we can rewrite this as 6 squared. So that kind of tells you it's negative 2. Remember, negative exponents give us reciprocals. This one, 2 to the 4th power, 16, but we want it to be flipped. So this one's going to be negative again. And then this one, we have to remember this property. Square root of x is the same thing as x to the 1/2. So 5 to the what power is 5 to the 1/2. It's got to be 1/2. Okay, so that's evaluating logarithms without using a calculator. Eventually we'll do some here with a calculator in the next lesson, but here we're going to stick with just trying to approximate. So what if we get some logarithms like this, where we think, okay, 3 to the power of what equals 40, and I don't know because it's not a whole number. It's not a negative number, it's not a fraction. I mean, it's a decimal that we can't write as a fraction. It's an irrational number. Means it's a decimal that doesn't repeat. And so we have to come up with powers that we actually know, like this. 3 cubed is 27, and 3 to the 4th is 81. So all we really can do here is say 40 is in between there. So this value must be somewhere between 3 and 4. Somewhere in between there. 3 point something. I don't know. And that's all I want you to do for this, is to say, like, which 2 consecutive integers, meaning numbers that are right next to each other. And I could have even said whole numbers because they're going to be positive in this case. So all I would expect you to say is log base 3 of 40 is approximately between 3 and 4. I know that for sure because of this. So then we have just estimating a few more, and then that's it for this. 2 to the what power is 10. A lot of students tell me this because 2 times 5 is 10, but this is not how logarithms work. So 2 to the 2nd power is 4. 2 to the 3rd power is 8. We're not there yet. 2 to the 4th power is 16. So now 10 is in between here and here. So that means the value of this log is between 3 and 4. 3 point something. That's all we can do for now. This one, 4 to the power of 2 is 16. So just start with powers you know, and now we can see already 32 is in between there. So this value must be in between 2 and 3. And I'm not saying 2 minus 3. I'm saying between 2 and 3. 2 point something. And this one, 3, let's start a little bit higher. 3 cubed is 27. 3 to the 4th is 81. 3 to the 5th, I don't know that one. I got to check my calculator. 243. So 100 is in between 81 and 243. So that means this value is actually in between the 2 powers that I just used to get that. So this value is about 4 point something. And it's probably closer to the 4 than the 5 because this got way, way higher. 81 is actually closer to 100. So it's probably 4 point, closer to 4, like almost 4.2, something like that. And eventually we'll do these on the calculator, and I can give you a beast TI-84, and you can do it. Okay, yeah, last thing is a little notation. If the base is 10, okay, and the base could be anything, but common log is base 10. So we write it like this without the base. If you see that, this means log base 10 of 100. So we're asking 10 to the what power is 100? And then we could do this without a calculator. This would be 2. And I can show you in class. When you have the log button right here, what you're saying is log base 10. Because it doesn't let you choose a base. You have to input the number right away. So it means base 10 because 10 to the third is 1,000, 10 squared is 100. So this one, log, and then 1 over 1,000. You could try to think what's that going to be. It's got to be negative, right? Because 10, whoa. What happened? 10 to the what power is 10 to the what power is 1 over 1,000. Well, we just did 10 cubed is 1,000. So this has got to be -3. And we can check on the calculator, -3. So this one, square root of 10. This is 10 to the what power equals square root of 10. So we could also do this without it because square root of 10 is 10 to the 1/2. So x must be 1/2. Calculator is going to tell us 0.5. So let me move this over here. Log of the square root of 10. So I got to have like double parentheses. It's going to tell me 0.5. Okay, so that's it for intro to logs.